All right, day 5 of final exam for the first semester review. Starting with inequalities. Graphing inequalities on 125, what do you want to always start with?
I just want to do
Yeah, sure. What do you always want to start with? The number. And then what do you want to look for?
the sign.
The sign. What does the sign tell us?
Open.
It's going to be open because there's no equal to underneath. Okay, and then is it in the way where we can trust where the arrow's pointing? Yes.
Yeah.
What way does our arrow need to go? Left. If I pick a value, I'm going to pick -10. Is -10 less than -6? Yes, so you know did that correctly. On 128, start with the number. Is it going to be open or closed? Closed. What's wrong with this one? It's on the wrong side, right? So I need to flip it to A is greater than or equal to -5. Remember, it's open to the A to start. It needs to stay open to the A at the end. And then where does my arrow go? To the right. I'm going to pick a point. 0 is 0 greater than or equal to -5. Thank you. Okay, 130. What's wrong with this?
There's a number with the
We got to get the variable by itself in order to graph. What do I do? Add 16. What's -29 plus 16? P is greater than or equal to -13.
Yeah.
It's in the right form that we want. What do I do with the number on the graph? Open or closed? Closed because it's equal to, and then which way is my arrow going to go? To the right. Okay, on these ones, we're writing it ourselves. What are the two things we start with? The letter and the number. Now, which way is our arrow pointing? Left, so we need to have our sign pointing to the left. And then what do we have to check? Open or closed? Is it open or closed? Closed, so I need to add the equal sign underneath. And then to check, I'm going to pick -4. Is -4 less than or equal to 3? Yes. So you know you did it correctly. On 134, what's wrong with this one? We got to get n by itself by doing what? Dividing by a -8. So we get n. What happens? Why does the sign flip? Dividing by a negative. So it flips, and then we get +11. Graphing. Open or closed? Closed, going right. Do not forget to flip your sign if you divide or multiply by a negative number. That's something you should probably put on your note card. Any questions on this page? Do a couple of these. Let's look at 138. How do we solve this one? Distribute. So I have 16 is greater than or equal to -40 plus 4x. Next step, add 40. So I have, not 66, 56 is greater than or equal to 4x. Last step, divide by 4, we get x equals 14. Oh, is it equal? What am I doing? X is greater than or equal to, nope. Holy moly. 14 is greater than or equal to x. What's wrong with that? Yep, that's what I was doing. Flip it. Now we can graph. What do I do on the graph?
Mark the 14.
14, open or closed? Close, going to the left. So that mistake I almost just did, I almost just assumed x was equal to 14. Remember, you're at this point right here, you still have x on that side. So don't skip that step like I almost did. Questions on that one? All right. Do I need to do any more of those? Oh, I do want to look at 144. What's my first step with this one?
Distribute.
Distribute. What do I get when I distribute?
-12.
Positive or negative?
12.
12b minus 4. Okay, what's an extra step we have to do?
Like terms.
Yeah, we got to combine like terms. We have 12b and b. What do I get? 13b minus 4 is less than negative 95. Next step, add 4. Yep, negative 91. And then I divide by 13. B is what? Negative 7. Graphing, open or closed? Open going to the left. All right, any questions on this page? I know I only did a couple, but we should all know how to solve by now. Okay, let's get into and or. Look at 148. Right, what is this one going to be, and or? It's going to be and because it's connected. Think of it as connected. So I have negative 5 is less than or equal to x plus 5 is less than or equal to 7.
Subtract by 5.
Yep, we still want to get x by itself, but we have to do it to everything. So I have negative 10 is less than or equal to x, which is less than or equal to 2. Graphing this, just take it one at a time. Negative 10, is that open or closed? Closed. Yes, and then looking at 2, is it open or closed? Closed. So did we do it right?
Yeah.
Yes. If this, looking at this right here confuses you, rewrite it as 2 different inequalities. Okay, so I can rewrite it as x is greater than or equal to negative 10 and x is less than or equal to 2. If you get confused with them together, just write them out separately. They're the same thing. Okay? All right, looking at 150. We have 2 of them. We have and. What's our graph going to look like at the end? Or what's it supposed to look like? It's supposed to be connected. So we got to solve both of them. What's the first step on the first one? Add 10. So I have 5v is greater than negative 30. And then divide by 5. V is greater than negative 6. Don't forget to do the other one. First step in the other one is subtract 10, and then we do divide by 5. We get 9. So let's just graph it separately. Negative 6, open or closed?
Close.
Open going
To the left. Right.
going to the right. 9. Open going. Does the graph look like what we want? Yes. On 152. Yep. Let me rewrite for a second. Okay, underline like terms. What are like terms? Yep. Which one do we want to move over? Yep, doesn't matter which one you do. Nope. Let's add 5p to both sides. So we have negative 8 is less than or equal to 7p minus 8. From here, what do we do? Add 8. We get 0 is less than or equal to 7p. Divide by 7, we get 0 is less than or equal to p. Do we like it like that? Nope, let's flip it. P is greater than or equal to 0. Is everyone okay so far? Yeah. All right, what can we not forget to do? The other side. So now we have 8 minus 2p is less than negative 10p minus 8. What do we want to do first? Combine the variables. Okay, which one do you want to move? You want to move 10? Add 10? So we get 8 plus 8p is less than negative 8. A lot of 8's going on. We want to subtract 8 over. Remember, we want to get p by itself. We have 8p is less than negative 16. divided by 8. So P is less than -2. So take them both separately and graph them. Let's look at the P is greater than or equal to 0. 0, open or closed? Closed, going to the right. P is less than -2. -2, open or closed? Open, going. Is that what we wanted our graph to look like? Yes. Now, something you might want to write down somewhere, or if you have your note card out, I'm going to go through these real quick. If I had an and statement, and I had my graph looking like this, can we have that for an and statement?
No solution.
No, so this one would be no solution. This is probably something you want on your note card. For or,
All real numbers.
right, if we have or is supposed to be going opposite ways, right? If they're going through each other, you know that it's going to be all real numbers. Moving to absolute values. Just like we talked about 2 days ago with equations with absolute values, what do we have to have?
2 cases.
2 cases. What's the first case always going to be? The same thing. So we have r is less than or equal to 3. With inequalities, what changes between the first and the second case? Oh. So sign flips and number sign flips. 2 steps. We got to make sure we do both of those. So what's my new sign for case 2? Greater than or equal to. And then what's my new number? -3. Do not forget to graph both of them. So at +3, open or closed? Closed, going to the left. -3, open or closed? Closed, going to the right. What kind of statement is this? It's an and statement. 156. What's my first case going to be? N minus 7. Yep, keep it the same. The second case, does anything change inside the absolute value? Nope, absolute value will always stay the same. What happens to our sign? Sign flips and the sign of the number flips. So from positive to negative or negative to positive. What's my only step I have to do to get n by itself on both of these? Add 7. So on the left I get n is less than or equal to 17. And over here I get n is greater than or equal to +3. No. Yes, this looks like a 17 to me. Are we okay there?
Yeah.
All right. We got to graph both of those. Start with 17, open or closed?
It's closed.
Closed, going left. And then 3, open or closed? Closed, going right. What statement is that? And. Any questions with absolute value inequalities? Can I move on to the last concept?
Yeah.
All right. With these, I'm going to look at 157 first. What form is this in?
Y equals mx plus b.
Our friend, y equals mx plus b. Is it graphed any different?
No.
No. Where do we start with the graphing?
-1.
What is the -1? It's that y-intercept, right? So graph down on the y-intercept at -1. That's your starting point now. Because remember, b and m. What do we do from here?
Rise over run.
Rise over run. First, is it going to be negative or positive?
Negative.
It's going to be negative, so we need to be going down. So what's my rise? 3. What's my run?
4.
In what direction?
Go right.
I need to go right. 1, 2, 3, 4. And then make another point.
Go up 3.
Yep, you can go the opposite way. Is our graph going to be the correct way?
Yeah.
Can I just draw a line?
No, I have to see if it's solid.
You have to see if it's solid or dotted. Let's make note of that.
Solid.
Equal to is solid. Anything else is dashed. So on 157, solid or dashed? Solid. What's my last step with these? Shading. Okay. What's the trick I showed you with shading? If it's greater than or equal to, where do we shade? Up or down? Up, and then left or right? Right. If it's less than or equal to, we shade up or down? Down, and left. Write that down so you don't even have to think about it on the test. Okay, I'll give you time to write that down. On 157, is it greater than or less than? Greater than, so do we need to shade up or down? Up. Now, looking at 158, what are we missing?
Y-intercept.
We're missing the y-intercept of the b in the equation.
Y-intercept.
We're missing the y-intercept. If we don't have one, what can we assume it is? 0. So our starting point is at 0. And then rise over run. What's my rise? 5 over
4.
which direction?
Right.
Right, 4. And then,
Down 5 over 4.
yep. What's my next question?
Solid or
Dashed or solid? What is it? Why is it dashed?
It's not equal to.
Not equal to. Last step. Shade. It's less than, so you go up or down? Down. Ooh, I don't like that noise. Any questions on this page before we check out the back?
The back is this.
Yeah, back.
You just have to solve it.
Let's do one of them together. Oh, we got to look at this one. This is something else I want you to put on your note card. If we have x, I'm just going to put this example. X less than 1. Draw a little graph. Where's x, where's 1 at on the x-axis? To the right 1. We're right here. That's the only x value I want to hit. So what kind of line do I need to have? Straight up and down.
Dash.
Yes, sorry. Let's change it to an equal sign. If it says y is greater than or equal to 1, where's 1 at for the y-axis? 1. And then that's the only y value I want to touch. So what way does my line need to go? Horizontal. Put those on your note card.